I want to do a series on partial fraction decomposition. And on page 495 in your book, you've got all the rules here. And I'm going to go through examples that tell you about all these things. But the first step is if you have an improper fraction, go ahead and divide that. And you'll see how these compare to other fractions you've done as we do examples. The next thing is always factor your denominator. You'll see that here in a second too. And then from there, there's kind of two scenarios that arise, whether you have linear factors or quadratic factors. Kind of like everything else we've done, linear factors are way easier to deal with than quadratics, but they're not too terrible. So we'll get through all that in examples. I've got a series I'm going to do here with a few different things. I'm going to start you off with a fairly easy one. And we've got 5/21. And the idea here is that that could be broken up into the sum of two other fractions. For that to happen, the fractions would have had to have had a common denominator of 21. And so we need to look at how can we break down 21 and get factors for it. Well, there's really only one way to do that. That's 7 times 3. So that means that 5/21 is something, I'm going to call it A, that's kind of the standard, over 7 plus something else b over 3. Since 7 and 3 are the factors of 21, something over 7 plus something else over 3, when added together, have to create something over 21. And this one actually gets pretty tricky to solve, so I'm going to stop right there. But for everything else, we'll take it all the way and solve it to the end. In example 2, we've got 10x over x squared minus x minus 6. So if this is improper, I need to divide the top by the bottom, but it's not improper, so we're good there. The next piece is going to be to break up this denominator into its factors, because if this was made out of two fractions added together, then their common denominator would have been this denominator right here. So here it is already done. If I factor that down, I get x minus 3 and x plus 2. So the idea is something, and I'm going to call it A, over x minus 3 plus something else over x plus 2. When these two fractions added together, they would create this fraction. It doesn't matter where you put A and B. I get that question a lot, usually in class at this point. You can put B here, you can put A here. It really won't matter. In the end, whatever A comes out to be will be the number that's supposed to be over x minus 3. And you can probably imagine that it kind of matters what's on top of each denominator. But as long as you do the work correctly, it really doesn't matter what you call these at the beginning. So just do your algebra correctly from here and you'll be okay. Well, we do have an equation at this point. So anytime I've got an equation like this with fractions, I'm just like, y'all, I don't really want to deal with fractions. So I'm going to multiply everything by x squared minus x minus 6 on both sides. And if I do that, that goes away, which is really nice. And I might want to think about it being factored on this side, but still I'm multiplying both things by that. So really, if I distribute, then x minus 3, x plus 2 here, those go away. And if I multiply this one by that, then the x plus 2 goes away. So hopefully it's not getting too messy here. You got 10x is all that's left on the left. And then we've got a times x plus 2 right here. And we've got b times x minus 3 on that part. Because if I multiply both sides by that same denominator, and basically I'm distributing it here, just look at the pieces that are common that cross out, distribute by what's left, and we get to here. All right, from this step, I've got 10x equals ax plus 2a and bx minus 3b. All right, well, this would have came in a chapter that deals a lot with substitution and elimination. I don't usually teach that in this class because usually everybody's pretty good with those rules. So we're just going to jump into some substitution, elimination, some systems of equations rules that you probably are familiar with. This first one might seem a little strange, but it probably seems like it would check out. All the things that have x's in them, I can go ahead and set those equal to each other, and that's okay. But then I've got the 2a and the minus 3b. Well, it's really kind of okay to say plus 0 over there. There's a 0, understood 0 as a constant, so that's what we're going to do. 0 would equal the 2a minus the 3b. And that'll be all right. That's supposed to be a 3 right there. Got a little messy. All right, so since all these have an x, I can factor it out. And really, we can just drop it. Makes it easier. All right, well, that's going to be kind of tricky to solve. But on the other side, 3b would have to equal 2a. And a would have to equal 3b over 2. I'm kind of playing pinball here, but I just divided by 2 and wrote the variable on the left. All right, well, if a equals 3b over 2, that can come back in on this side. So 10 is equal to 3b over 2, because I know that's what a can equal, plus b. All right, well, I need this to be over 2, so I need to make it 2b. So 5b over 2 equal 10. Multiply both sides by 2. We'll get 20 equals 5b. So b has to be 4. All right, we've got that concluded. And then a was sort of unfinished over here. We know it's 3/2 b. So let's put in b and see what happens. Well, that's going to give me 6 for a. Okay. Either cross out your 4 and 2, 3 times 2 is 6, or 3 times 4 is 12, divide that by 2 is 6, however you want to work that out. But I've got my a and my b. In the beginning, I told you it really didn't matter what you call a and b. What really matters is, as you do the equation, you'll get the correct number that should be over top of each piece here. So 6, and this is how we need to end this up. 6 should go over x minus 3, and 4 should go over top of x plus 2. And that would end it up. You can check these if you want to. Most of the time, I don't think you're going to find it necessary. But if you did go back and get your common denominator, it would be the x squared minus x minus 6. And if you did all the fun stuff that entails, you would eventually end up with 10x on top. It would check out. Now for example 3, we've got 3x squared minus x plus 5 over x cubed minus x squared minus 2x. All right, this one's got a little bit more going on for the denominator, but if I factor that down, we're going to get a common x we can take out of both. And you can do this off to the side or wherever you want to. I just want to keep it out of the main work because sometimes these get pretty lengthy. All right, well then that binomial can be broken down more, x minus 2x plus 1. All right, so those are my 3 factors. So something over x plus something else over x minus 2 plus a third thing over x plus 1. So again, because that denominator can break into these 3 factors, we could have had a blend of up to, and I guess it probably would have had to have been 3 fractions that had these 3 specific denominators. And that's where we go next. So again, multiply by that common denominator. And I'm going to do it a little different this time. I'm going to write it just the way you see it over here so that that cancels out. On this side, I'm going to go ahead and do the factors separately. And this is where it gets fun between a blend of getting too messy and making sure y'all can understand what I'm doing. So I multiply the entire side by x times x minus 2 times x plus 1. And I'm gonna go ahead and begin the next step, and hopefully this is okay. I can always clarify stuff later, I guess, if I need to. The x here and the x here would cancel out. So you would have a times x minus 2 times x plus 1. That's going to probably be the worst one. Next, you would have b times, well, the x minus 2 would cancel out, so b times x plus 1. And then with the c, the x plus 1 would cancel out, so times x minus 2. And if you look at this and think it would be easier to say x squared plus 1x, that's fine, you can do that. It is getting kind of messy looking here. So I'm going to bring in my scratch paper again if you need it, because I want to make sure I get this expanded out. I will need to go ahead and do this expansion. It really won't make it any easier if I don't. So plus x minus 2, so x squared minus x minus 2. That's what this will expand to be. So putting it all together, 3x squared minus x plus 5 equals a times x squared, and then negative ax, and then negative 2a, plus bx squared, and you can expand that the same way if you need to, plus bx times 1. Cx times x is cx squared, and cx times negative 2, so negative 2 xc, or cx. I guess I'm going to try to keep it the same order that I have these other ones in. All right, so always good to do a little double check here and make sure everything's looking good. This is the easiest place to mess up. So, and once you mess up here, of course, it throws everything off. All right, so I feel pretty good about that. So I'm gonna move on to the next piece. So first I've got 3x squared, I've got ax squared, I've got bx squared, I've got cx squared. So 3, I'll go ahead and put the x squareds in it for now, would equal ax squared plus bx squared plus cx squared. All right, so that's one statement, one equation. And next we have negative x. That would equal negative ax plus bx plus minus 2cx. Okay. And then we also have a constant at the end. Let's see if I got enough colors here. We've got this constant 5. So 5 would equal negative 2a. And that looks like it's the only constant we have. We used up our x squareds, we used up our x's. That's the only one left to be a constant. So this is kind of the key of the whole thing. This is where I'm going to start. It doesn't have to be the key, but it just seems like the logical place to begin. 5 over negative 2 would be a, and that's a done deal. I can circle that and say, hey, there's a. All right, well, now that I know that, I'm going to go work on some of these. So I can get rid of the x squareds at this point. These all have x squareds in them. I'm going to go ahead and put that negative 5 halves in for a here, because I know that a does equal that. It's got to be true. Plus b plus c. And on this one, keep the same colors going here. So negative 1x, it's kind of understood 1, don't forget that. So negative 1, because I'm going to take the x's out of all these, is negative a, which is negative 5 halves, so positive 5 halves. Be careful with that sign there. Plus b minus 2c. Okay, so we've got a system here, and got a little bit of fractions, but we can do elimination pretty easy, it looks like. So maybe a little bit of work, but we'll put it together. Let's move this one over here, and let's see. I've got, if I had a negative b, that would be awesome. Or I could multiply all these by 2 and have a positive 2c here and a negative 2c here. I kind of like that because I can get rid of this fraction. But then again, that's going to keep a fraction in the problem. I mean, and these are things I'm just looking ahead to what I might encounter down the road. I mean, you can always just dive in and see what happens. So looking at it that way, I'm going to make this a negative b here. And to make that happen, I need to multiply all these by negative 1. So just multiply by negative 1 on both sides. And it's an equation, so I can do that. Whatever I do on one side, just do it to the other. So negative 3 would equal positive 5 halves minus b minus c. Okay. And if I bring this one down now, negative 1 equals 5 halves plus b minus 2c. Okay. So I got a system now. I can add the two equations together, or we'll do elimination with this system. That's going to give me negative 4 equals 10 halves, so 5. B's add to 0, and minus 3c on the end here. Okay. So I'm going to subtract the 5 on both sides. Negative 9 is going to be negative 3c, so c is going to be 3, and that one's done. Okay, so the only thing left now, and really I can go anywhere, but the logical place to go would be this part. So negative 1 equals 5 halves plus b, which I don't know yet, minus 2c, which I know is 3, so we'll put that in. All right, so let's see what we got. 5 halves plus b minus 6, and I really don't want to deal with that fraction yet, so I think I'm going to boot the 6 over, add that to both sides. It's just preference. You can do whatever you want there. So 5 halves plus b. I still got to deal with that fraction though, so it really didn't help me a whole lot. Subtract 5 halves from both sides, and that's going to make this 10 halves. So 5 halves would be b. All right, so we do have a couple fractions in this. That's kind of new. A was negative 5 halves. B is positive 5 halves. C is 3. Okay, so just think back to the beginning. Just be careful what you called A, B, and C. Really just what you put it over top of. That's the main thing. So A was over x. So negative 5 halves goes over top of x. All right. Another little complication here. All right, well, how do I do negative 5 halves? Well, 5 halves is already a fraction, so I'll just say negative 5 on top, 2 on the bottom. And that's okay. You can do that. All right, plus b is going to be over x minus 2. Same deal. 5 halves and the x minus 2 is on the denominator with the 2. So just put it like that. Generally, we just leave it that way, but if you feel better about saying 2x minus 4, that's fine. And the last one, c, is 3. So 3 over x plus 1. And that should do it. Make sure you can see the whole answer there.